Hello and welcome. I was walking here in the forest just searching for the next place where I can find a good place for a talk. I want to talk a little bit about some coding stuff, and I found this place and I thought this is a perfect place for how to start hunting mutations. And this is a thing I want to explain today, how to start hunting mutations. So, my name is Sven and I'm developer advocate at JFrog. And I'm specialized for DevSecOps and have a long history in core Java, QM, QS, this is quality management stuff. So, if you want to learn more about this coding style, just start subscribing my channel. And we want to start now. Mutations, mutation testing. First of all, I want to explain why I start thinking writing or creating this talk. It's a story that's a few years ago, and it I will explain what was the base and the biggest project where mutation testing really helped me. Then a small example so that you can test yourself how good you are already with this stuff, and then the basic idea. I just mentioned what's the basic idea of mutations and what you can do, what kinds of mutations, so for example how to modify all this stuff and what the theoretical background. Just mentioning two frameworks, one for research, one for usage. After this, a small demo so that you can see how this is, how this looks like for you as a developer in a daily life. So how you can handle this one, what kind of report you will get, and all this stuff. And a short lesson learned from my experience. And maybe you can write down in the comments what's your experience with mutation testing a little bit later, or already if you're using it. So, yeah, last words are about how to start it in your project. This is just a few lines how to ramp up your Maven project. So, story behind this. A few years ago, I was head of R&D for a little bit bigger company, and they had a product that was running since more than 10 years. And it was a Java-based product, so it's entirely written in Java. And I don't want to mention what kind of company or product is, but the main thing here is after this over 10 years of development, they had 0 tests. Really, not only one JUnit test, there was no test, nothing. There was just a piece of paper where you can write down, I tested A, I tested B, I tested C, this testing protocol, that's it. And this since a long time. So, and well, the other thing is that there was no dedicated refactoring or cleaning up budget, so there was never time to remove some stuff or to clean up or to refactor to get better source code, whatever. So it was just not existing. So, and and over the 10 years of development with a bunch of developers, it was just a complex base. So here tiny bug fix, here an edit, if, else, branch, whatever thing, and the whole source code was just, it was really a big mud of lines of code. So for me the question was, what's the best place to start, how to start, and what's the best place to start cleaning up and prepare for the next generation of this product. The next thing was how to find out where is the biggest risk in this hundred thousands, or I think even a million lines of code. So where's a risky place, and how to motivate the team. So if I would just start with Sonatype and recognizing 200,000 defects after 2 weeks of working, and you just kill 10,000 of 200,000 defects, this is not motivating, so nobody will follow this path. So what I needed was some kind of metric, some kind of tooling that will help and that is good for reporting, and something that I can use for the management as well as for the developers. Tiny example. So this is a typical piece of code, business logic. There is no mathematical background, there is no physical thing, there's nothing that you can use as reference. It's just a piece of code that should do something, text rule or whatever. And the only thing you have is a description what should be done, and then maybe some tests to verify if this fits. So how many tests you would need for this piece of code, and what are the good tests, what are the right input values. If you want to make this test, if you want to do this test for yourself, press the pause button, the hold button, grab a piece of paper and a pencil, and just write down how many tests you need and what are the input values you would choose if you are the developer that must test this piece of code. Okay, I assume you wrote down already how many tests you need and what are the right input values. So the thing is how to make sure that this is always the same, depending on, for example, the day you're working, the time you're working, if you're in a good mood, if you're in a bad mood. So how to make sure that if you're writing tests for this piece of code, that the quality of this one will be always the same. This is a tricky thing. Think about, you had a big party of the weekend, you had just one day to recover, and then you have to give up your work or to produce this test coverage, or you are in the middle of the week or Friday and you want to go to the weekend. So whatever it is, you have trouble at home or whatever. So we are humans, we are not delivering always the same quality. So we need the machine that will help us, and mutation testing is one of the tools that will help you in a really good way. So I started this one by myself, so I just took two tests here, 0, 0 and 3, 0 as input values. Is this good? Is this enough? We will see. The basic idea behind mutation testing, so that you have an idea why it's different to pure line coverage. So mutation testing is a structural testing method. It means it will not help you to get the best match between the user requirement and the source code you're writing. It will give you the best match between the source code you wrote for the use case and the test that is testing this piece of code. So this is the target of mutation testing, to test that the test fits as best as possible to this piece of code you want to test, nothing else. So it will help you to find the good tests. So what are the good input values? And the good thing is the machine will help you to find these good tests. And this is one thing that is really convenient here, because the machine will do a lot of work for you and give you quite good reports so that you can work. Just to make it a little bit more formal here, this place, so we have P, the program, and a mutation is just a tiny change in this program. It's a tiny defect, so you're changing a plus to a minus or whatever. You don't have two changes in your source code, you have only one thing, and then you're talking about a mutation. P1, P2, P3, and so on. So for every mutation or possible change, you're creating a mutated version of your program, and you need a test coverage, T. And this test coverage can be just one single test that's always green. Even this is enough to start with mutation testing. If you're doing this one, for example, you have a few lines of code and you're just writing one test that is constantly green, you're creating the mutation test coverage report. What you have is a matrix of risk. So you see immediately, I have so many mutations here and so many mutations are there. And then you can compare this one. And if you're searching for the place with the biggest risk, because it's the most complex piece of code or the most shitty written one, then just follow the mutation test coverage report. Where you found the most mutations, this is a critical thing. So, what's good, what's bad with mutation testing? So if you have this mutated version, so you have changed a plus to a minus, and you are running all your tests against this program, if one test is failing, this is good, because with this you are able to detect if you're delivering P or PN. If all tests are green again, then it's bad, because you're not able to detect this mutation based on your test coverage. That's the basic idea. If you're killing 100% of mutations, then you have 100% of mutation test line coverage. This is like 100% line coverage. Well, it's a theoretical thing, and practical, you have a border that is below. So what is the basic workflow? What you're doing is quite easy. You're generating the mutations, you're running all tests against it, then you're checking the reports, see, okay, there's this mutation, then you identify what test you have to write to kill this mutation. You're doing this one, you're running this mutation testing again, you see, okay, mutation is killed, that's it. So this loop is constantly done, and the good thing is it's exactly the same what you're doing for TDD. You're writing a test, You're running this system, you're checking the report, that's it. So there's no process change, it's just an additional tool in your chain, but the process of coding is exactly the same. This is good. If you have 100,000 lines of code or a million or whatever, then it makes sense to identify in between modules what is amount of mutations per 1,000 lines of code, because then you have a normalized thing, and with this you could do the following. For example, here module A has 20 per 1,000 Ks of line, and B 10 mutations, and module C has 30 mutations per 1,000 lines of code. And then you can sort it. So everything with a high amount of mutations is a complex thing, and there is a high risk. So use exactly this one and compare it with, for example, sales, that is saying, okay, in this module we're expecting changes because the law is changing, the customer needs some changes or whatever, or this module we will never touch and it will be decommissioned soon. And then if you have at the same time the amount of mutations per 1,000 lines of code, then you know the balance between we're expecting change, it's a high risk, and then you have a list or an order of modules in which order you should start cleaning up or have them focus on, or where's the highest risk based on amount of mutations, test coverage, the amount of changes you're expecting, and so on. And this means you can use exactly this metric from C-level down to developer and back. So for all levels you can use this report, and this is really good if you have to decide how and at what time and what place you have to spend money and resources. What kind of mutations you can generate? We have this language independent mutations, means that is just the same for every language. For example, you can change values. If you have a loop, do this until 10 is reached, you can just change this constant 10. You can make a -1 out of it or whatever. So all these constants or loop boundaries and all this stuff, you can just change the fixed number there. The next thing is you can change decisions, smaller to smaller equal. If the test is not failing, then the values are too far away from this border, so you're not detecting the difference between smaller or smaller equal. And then what you can get is deleting lines of code, swapping lines or duplicating lines, all this stuff that will happen during refactoring, bug fixing and all this stuff. So these are the language neutral ones. And then we have, for example, the Java specific ones. It means for every language, if you have a mutation testing framework, you have this language dependent or this language specific mutations as well. So for example, here we have changing modifiers. This is one thing. You could have a change between static and non-static. So something is not static, you're making it static, and see what concurrency is doing, for example. The initialization of members. In this project, every member will be initialized with -10. Good. And everybody will just think about this and is, yeah, well, maybe it's not a good idea, and this you can check here. One thing is with lambda expressions and anonymous classes and all this stuff, this dot construct. So if you're chanting this one, sometimes you have the just different borders where you're grabbing your reference from. And one thing that is really, really nice, I personally like it, is argument order change. So it means you have a method, for example, with param C of type int, param A of type int, and param B of type int. And then you have a colleague that's just so happy with clean code, and he cannot resist, and he's just refactoring it to A, B, C instead of C, B, A or C, A, B or whatever it is. And all modifiers are, all params or all arguments are int arguments. So to find this one is just a challenge, and this with mutation testing is very easy to identify and make it robust. So this is something nice. So the main thing is, as I mentioned, mutation testing is just an add-on to TDD, so it's no replacement, it's an add-on to JUnit. So it's not replacing JUnit, it is using JUnit. And yeah, tools are supporting it well. I will show you one tool that's really good there, and using and you can use it even with new JDK versions, so this tool is really good supported. So one bad thing with mutation testing is that mutation testing itself is very time consuming. So the amount of mutations is has exponential growing. So double amount of lines will lead to not only the double amount of mutations normally. So, and this means you have, with a huge amount of lines, a very high number of mutations. This means a really high number of runs against your test suite, or the test suite against this mutation. And yeah, make sure that if you're starting with mutation testing, don't grab the whole product, start on Monday morning and just kill the CI server with generate the mutation test coverage report. Maybe you should start with a smaller module, have your feedback, how long it will run, and all this stuff. Yeah, so this one. One thing that is very important over the time, if you're using mutation testing in your team, the team will start making small modules instead of big ones. So this is one of the really implicit but very good things that are coming out of mutation testing. So frameworks. Mutation testing is, from the theoretical point of view, a very, very old thing. So it means the first documentation about mutation testing is from the 70s, I think. So it's older than I am. And for IT, this is really long time. So the theoretical part is quite old, and it's very strong, with a strong mathematical background. And this is a very, very good thing, because if you think about property-based testing, for example, you have this random number generator, and normally if you want to have this one that to fit to your challenge or to your problem, the random number generator must fit to the problem you want to cover or to solve. And nearly nobody is able to write a proper random generator for a dedicated problem. So you're using the generic one, but is this a good one? Fit this random number generator to your problem? Can you rerun test again and again? No, because it's not reproducible, and so on and so on. So there are some challenges you should have in mind. But with mutation testing, for example, this is just plain mathematics, the same stuff. So you're changing A to B, you're doing this and then that. And every mutation is completely atomic, so it means you can run all mutations completely independent. They are not depending on each other. That's a good thing. So during the 2000, 2003, 2004, a lot of projects started, and maybe it was some research done there, or some money for research, or it was cool these days. I don't know exactly. So a lot of frameworks start. For example, MuJava, what I'm showing you here right now, as well. So it started 2003, but then all projects died more or less around 2007, 2008. Most projects died. I think it was not fancy, there was no research money anymore, or whatever. So the projects died. This one is still existing. It is on GitHub, and this one is following the approach that they are changing the source code and then compiling and running this stuff. And this was just a bad idea. The only thing why I'm mentioning this is you are able to find the source code, and with this you can do your own research, how they minimize the amount of mutations, how they identify them, how to scan the source code, and all this stuff. So for research and using this one to learn, that's good. But don't use it in production. Please don't do it. If you want to use something in production, and I really recommend this one, there is one project that started 2012, a little bit earlier. It's not really written down, but it comes from the field of massive parallel integration testing, or this parallel integration testing framework. And this is where the name is coming from. It was a framework to ramp up a huge amount of tests. So this person started writing a strong class loader, isolate tests really good, run them concurrently and all this stuff. But then it turned out that this is a very good base for mutation testing. So 2012 he started, and it's just active. So if you have a new JDK version, he's delivering very soon an actual version of this one. It's called PyTest. he got the Java champion for this one, for just mentioning. And the main thing is that this is working on bytecode, so he's not changing code and compiling, because if you're doing some, or if you have a change that will lead to a failed compile, there's a different thing than a non-executed test or red test. So this one is just changing bytecode, so you don't have this compile cycle and you don't have this mistakes, and then he's just running the test. So this one is really good, and I will show you how to ramp up this one. So back to the example we had in the beginning. So how many tests we need and what is a good input value. This is the main thing. So if you're looking at line coverage, then you need exactly 2 tests. Why? You have an if and an else, so you have 2 paths, and for 2 paths you need two tests. Means the amount of paths in your program is a minimum amount of tests you need. If you have less, something is bad. If you have more, then there is only the question how much more. So how many tests you really need. It means if you have 2 passes and you have 100 tests, maybe something is wrong, because even this does not fit. So line coverage, 2 tests. I started with these 2 tests here, 0, 0 and 3, 0, and this will lead you to 100% line coverage. This is one thing. So I generated here the line coverage report, and this one with JUnit. JUnit is for line coverage really the best tool you can use, and the only additional information you will get here is branch coverage, this yellow line here, and this is the maximum you can get out of line coverage. That's it, no more information. And if I'm adding the second test, so 0, 0 and 3, 0, then I have exactly green and 100% line coverage, a green report, and this is, well, from this perspective, that's perfect. But if this is really good, so I started with mutation test coverage, exactly with this one, and the main thing here is how this will work now, so, and how this report will look like for you as a developer. So I start with this one, and then to generate this mutation test coverage report, we have this pytest double point mutation coverage. This is a target on Maven. Then it will generate the report, run all tests, and under target/pit-reports you will find an HTML report. So, and the good thing, first of all, in this piece of code we are just looking at, you will find 54 mutations, theoretical ones, but the framework will eliminate all useless mutations, and you have just 7 active mutations. And we killed with these 2 tests, 0, 0 and 3, 0, just 3 mutations. That's it. The rest still alive. So I have here a few of these mentioned. These are the default mutators that are active. You can change the mutators. So you can say I don't want to mutate constants, and you're deactivating it, or you have your own one, and so on, and some experimental one. So you can activate and deactivate. For this test I just use the default one that I mentioned here. So how it looks like. The first thing is you will get this HTML report under target/pit-report, and you will see here this class, it's called service.java. You have 100% line coverage, and you have 3 killed mutations from possible 7. This is the first overview. If you're clicking now on the service.java, then you will see that you have this source code listed, and then you see the line number, and the next one is amount of mutations for this line, and then you see a green or red one, and here all are red because too many mutations survived. So there's not even one line that's fully covered. So if you have this one, then you can click on these 2. For example, in line number 8, you have these 2 mutations. You can click down there, and then you will get the detailed report a little bit below in this page. And then you see really per line of code and mutation, what kind of mutation, and if this one is killed or not. And with this you have a strict order what you should do. So really, okay, now I'm killing this mutation. This mutation is changing the loop boundary. and then you're writing a test against it. If you're doing this one, I just have done it. So for example, first I killed the first one here in line number 8, so that both are green, mutation 1 and 2. And that means I need the test 0, 0 and 2, 0, and it means test 3, 0 I can just delete because it's more far away from the border, so I don't need it anymore. And this you can do so again and again. So then I worked against the next one, I killed the next mutation, and so on and so on. So you can do this more or less by yourself, so step by step. But in the end, I had the values 1, 1 and 2, 2. This is the best mutation test coverage I can reach. And then you will see that there's one line that's constantly red. And if you're checking here this one, you will see I have this mutation that will change a multiplication by a division. And if I multiply or divide by -1, it's always the same. So I can't write a test that will just kill this mutation. And that's reality. So you will find places where you can't write a test against this mutation because it's a mathematical background or the algorithm or whatever. So what you can do, you can ignore it, you can disable the mutator, you can refactor your source code, but in the end you must have a decision. So you have to decide how to deal with this, and 100% line coverage is mostly not reachable. So what we learned so far. This piece of code I'm showing here right now is one piece that I just grabbed out of this huge project, and then I took a few engineers and told them, okay, please refactor this piece of code because it was not clear what's done. But this utility method was used everywhere. So what we have done is we started writing test against it, and then we activated mutation testing and we saw how bad our own tests are, and then we made a way better test coverage. And with this test coverage, we started refactoring. And after the refactoring, we had the old version, we had the new version. This is a new version I'm showing you right now here. And what we have done is we had a brute force attack. We took all the input params we decided to test and just compared the results to make sure, okay, this is really exactly what we are expecting. But mutation testing is more or less this one that helped us, because with the old test coverage, we aren't able to write this or to do this work. So this is one thing. If you're comparing both versions, it is very significant what you can see. So the version 1 was a for loop, and inside it was an if, and another if, and else, and inside this else a few ifs and all that. This was really grown source code. And the version 2 was very structured. So an if else, one for loop with one if statement, one if else, done. And if you're comparing both structures, it's way easier to test the second one. So mutation testing will definitely lead to cleaner code compared to pure JUnit. The next thing is smaller modules are the result, because you want to reduce the runtime and then you can spread it over different nodes, so to have more concurrency. So small modules are more or less an impact, or it's what's coming out additionally. And there's one nice thing what you can identify with mutation testing as well. It is if you're looking at the source code I'm showing you right now here, you have a hint anyway with red and green, but if you're zooming in, you will see that you have this: if something is bigger 0, the length of a collection, and then iterating over the collection, it's just useless, because if the amount of elements in the collection is 0, then iterating over it is doing the same, so you don't need this if in the beginning. Sometimes you have a few lines in between because it's just after bug fixing or whatever. But the good thing is mutation testing will lead you to exactly this point, because you're not able to kill this mutation because it's useless. And this is one additional nice thing. Mutation testing means that you're focusing on input values. If you're combining this one now with SecurityPayload testing, this is a beast. It's really cool. So have in mind, you have, for example, loading an image, and you want to make sure that if you are loading modified byte streams and you don't, or you have SQL strings that are injected in your method and all this stuff, use this one in combination with mutation testing. So generate your security payloads, put them, for example, in generic repository in Artifactory so that you have the security payload to the version of your source code, and use this one as input for your mutation testing. Then you have two goals. You have your hardening in your you're securing your implementation, and at the same time you're checking if this one is killing mutation as well. So both together is a really cool thing. With JFrog we will help you with, for example, not only Artifactory for the repositories, but as well for X-ray. X-ray scanning, for example, the dependencies. So everything, so you have a Maven repository. You're saying, Maven, please go over this one, and then this is your entry. That remote repository or this cache. And then with X-ray you're scanning the binaries internally or inside your IDE. You're scanning your dependencies. Means if you have a dependency that is using, for example, one example, you will find in my YouTube list a demo, and I showed how to harden a Vardin app. Vardin is a web framework based on web components and a Java backend. And I just scanned this one, and you see that, for example, it's using internally Jackson data bind, and there's so many issues with serialization and wrapping and all this stuff. And then if you have this knowledge, you can write explicit tests against it, and then the combination between the mutation testing in conjunction with or in combination with the security payloading, this is really a really hot topic. So this one you should do. And X-ray is, for example, just giving you a list what known issues in this library, and you can remove this one if this is, for example, fixed. To try it out, just go to jfrog.com platform free trial. It will take 10 minutes, 50 minutes, then you have a trial, and then you can explicit test, for example, with X-ray your dependencies, and then start using this one for your testing test suite as well. So how to start in your project with PID report. So the main thing is that you need JUnit to generate the reference. It could be JUnit 4 or 5. Then the next thing is that you're adding to the build plug this build section, the PyTest plugin. The next is configure the plugin. I will show you. It's just copy paste and changing two params. And after this you can generate the reference. It must be a green run with JUnit, otherwise PyTest is just stopping. And the next one is generating mutation test coverage report, and that's it. And this you will do again and again, and the reports are the target/pid-report. So, okay, copy paste from the homepage for this plugin, so this PyTest plugin. What we have output format XML and HTML. So if you want machine processing this stuff, just generate the XML one as well, because then you can process this easier. And then you have to say what's my production code and what's my test code. So that's it. Yeah, in Maven you have to add this one to the reporting section as well to get this output. And then what you should do, you're writing a test, at least one, you're generating the report, checking, and you're writing an additional test for the next mutation you want to kill, and this you're doing until your quality gate is reached. So just again and again and again. If you have time, you can remove or delete useless tests for your reporting, but mostly you're just adding at the beginning so that you're doing. One thing that's very important, if you're killing one mutation or writing a test against one mutation, it could kill different mutations as well, but never do it reverse. So don't try to kill with one test different mutations. It's just not working. Runtime. I have an example on GitHub, for example, this dynamic dependency injection framework. And the test coverage is, I don't know, 90% or so. And the test coverage will take 40 seconds, and the mutation test coverage report 3.5 minutes. And then you can use this project just for playing around, configure some mutation test coverage so that you have a plane, or just start with your own project. It's way better. If you start comparing, don't do the mistake and compare the line coverage, for example, between Jacoco and PyTest. There is a difference. Don't spend time on this. There is just a difference. I don't know how they are counting or what's exactly the difference. I'm just using one tool, Jacoco, but then not mutation test coverage if this is not allowed in a project. But if I can use mutation test coverage, I'm just using PyTest report, and that's it. So, yeah. If you want to deal with different languages, a really cool thing is you can use it for Java as well as for Kotlin, and you can use pit report for the same. I have this example here just as an example, so you can see that the report is more or less the same between the Java and the Kotlin version. Well, I wrote both pieces of code nearly in the same way, so no fancy Kotlin stuff, functional stuff, so just the same, so that you can see. But you'll see that it's the same behavior, it's the same way of working, and it's the same report. And even if you are changing from Java to Kotlin or from Kotlin to Java, or you're using it mixed, you can use this tool for different languages, and this is a really cool stuff. So this is more or less all what I want to explain about mutation testing. If you want to have more of this stuff, write it down in the comments. I really would appreciate if you subscribe my channel. I have a German one as well, so if you have German speaking colleagues, you can go to this one. Otherwise, the best way to reach me is Twitter. And if you have some other ideas about TDD topics I should make a video about, just let me know. And otherwise, have fun and see you. Today we want to see how to create a unit test engine for JUnit 5. That means in the beginning we will have a short introduction about the possibilities of the default test engine. The agenda for today. Why we need different repositories, what's influence and what part of the infrastructure is. The next thing is why you should have an eye on it. What will this series about? It will be about functional reactive, and this for core Java.